Hello students, welcome back to the next module of the chapter Oscillation. In this module, we'll continue with numericals on velocity. So let's start with the first numerical. The acceleration of a particle in SHM is 8 cm per second square when the displacement is 2 cm. If the amplitude of the motion is 5 cm, find the velocity when the displacement is 3 cm. So let's start with given students. As you can see, acceleration is 8 cm per second square. So the value of acceleration is 8 cm per second square. When the displacement is 2 cm, so the value of x is given to us as 2 cm. Also amplitude is 5 cm. So capital A is equal to 5 cm. We are supposed to find the value of velocity when the displacement is 3 cm. So I want to find the value of v when the displacement is 3 cm. So when say x1 is 3 cm. Let's start with the formula, students. As we know a and x are given to us, I will use the formula of instantaneous acceleration. A is equal to omega square x. Also, v is to be calculated, so I will use the formula v is equal to omega root of a square minus x square. Let's start with the solution, students. So, a is equal to omega square x. The value of a and x is given to us. So, the value of a is 8. So, I will write the next step as 8 is equal to omega square into the value of x is 2. The next step, students, so omega square becomes 8 upon 2, which is nothing but 4. So omega square is equal to 4. Taking root on both sides, we get finally omega is equal to 2 radian per second. Now let's move on to the formula of velocity. V is equal to omega root of a square minus x square. Now look, students, if you look at the right hand side, I have already got the value of omega as 2. In the given part, amplitude is given as 5 and the corresponding displacement for the given velocity is 3 cm. Let's substitute the respective values now. So v becomes v is equal to omega value is 2. So 2 root of 5 square minus 3 square. 5 square is 25, 3 square is 9. Therefore, the next step becomes v is equal to 2 root of 25 minus 9. 25 minus 9 is 16, student. Therefore, the next step v is equal to root of 16. We know root 16 is 4 and hence v is equal to 2 into 4, which is nothing but 8 centimeters per second. Therefore, the required answer of this problem, the velocity at displacement is equal to 3 centimeter is nothing but 8 centimeters per second. Let's move on to the next numerical, students. A particle in SHM has a velocity 10 centimeters per second when it crosses the mean position. If the amplitude of the oscillation is 2 centimeter, find the velocity when it is midway between the mean position and the extreme position. So let's start with given, students. As you can see, velocity is 10 when it crosses the mean position. Students, remember at the mean position, we have already studied the velocity is always maximum. That means indirectly the value of Vmax is given in this numerical. So remember, students, velocity is 10 when it crosses mean position. That means we are given with the value of Vmax as 10 centimeters per second. 10 centimeters per second. Also we can see amplitude is 2 centimeters. So A is equal to 2 centimeters. To find, we have to find the value of velocity. So to find this instantaneous velocity v when particle is midway between mean and extreme. That means when x is equal to a by 2. Formula. As Vmax is given, we will use Vmax as a omega. Also, we want to find the instantaneous velocity. So, v is equal to omega root of a square minus x square. So, let's start with the solution, students. To begin with, we know Vmax is a omega. We know the respective values of Vmax as 10 and amplitude is given as 2. So let's move on to the next step, students. So the next step becomes, therefore I can write 10 is equal to, that is 2 into omega, therefore omega becomes 10 upon 2, which we know is phi, and hence omega is equal to phi radians per second. Now let's find velocity. So let's use the formula, v is equal to omega root of k square minus x square. Now on the right hand side we know all the terms. Now omega we have calculated as 5, amplitude is given as 2, and x is a by 2. Let's keep the right side in terms of a only. So I can write v is equal to phi root of a square minus x is a by 2, so a by 2 square. Next step I can write it is as v is equal to phi root of a square minus a square by 4. A square minus a square by 4 will be root of 3 by 4 a square, which in the next step becomes phi root 3 by 2 into a. Now we'll substitute the value of a as 2, and I can write the next step as 5 into root 3 by 2 into 2. I will cancel 2, and the next step becomes v is equal to phi root 3 centimeters per second. We know root 3 is 1.732, therefore v becomes 5 into 1.732, and this multiplication is 8.66 centimeters per second. So the final answer is the velocity is 8.66 centimeters per second when the particle is midway between mean and extreme position. That's all in this module, students. See you in the next one.